Hello, I'm Jyoti. So this is lecture 4 of investigating and manipulating materials in the nanoscale. So the we in last lecture we have seen one component of ACM, scanning electron microscopy, which was, what was it? Electron gun, right? So today what we are going to talk about is second component, that is electromagnetic electron lenses. So this is the diagram for electromagnetic electron lenses. What does an electromagnetic lens consist of? So basically an electromagnetic lens consists of a coil of wire. See the coil of wire generating a magnetic field enclosed in an iron casing. A magnetic field is generated between the pole pieces by applying a current through the coils. The electron in the magnetic field undergoes rotation. How the focusing is achieved? So here focusing is achieved by varying the current through the coils. It is important to note that the focal length is directly proportional to the accelerating voltage. So the image quality is affected by varying the electron density. Now basically when we are talking about lenses, electromagnetic lens, basically we have to take care of the aberrations. So lens aberration. Electron optics suffers from aberrations, but in case of light optics there is a way, but unlike in light optics there is no way to solve these aberrations. Only what you can do is you can reduce aberrations, but you cannot make them completely zero. So let's talk about spherical aberration. Electrons in far away trajectories from the optic axis are bent more strongly. As a result, the electron beam entering the lens near the edge of the lens is brought to focus at a different spot than the spots closer to the center. The error in the image due to this becomes more pronounced as the beam is moved further away from optical axis of the lens. The image appears as a disc and not as a point. So that is spherical aberration. Now, how we can reduce or minimize this spherical aberration? So what we have to do, by placing small hole aperture at the center of the magnetic field or immediately below it, you can reduce spherical aberration. However, a smaller diameter reduces the beam current and also leads to aperture diffraction. So aperture diffraction is also one more kind of aberration. So that is also the problem. So you cannot reduce spherical aberration to great extent because that will cause aperture diffraction. Next one is chromatic aberration. This aberration is due to the energy spread of the electrons. When light of different energies enters a converging lens at the same point, the extent of deflection will depend on the energy. In light optics, radiation of shorter wavelength is deflected more strongly than that of longer wavelength. Exactly opposite happens in case of electron optics. So in case of electron optics, the reverse happens, that is a shorter wavelength is deflected less strongly. Due to this aberration, again you get a disc instead of a point. So how chromatic aberration can be reduced? By stabilizing the energy of the electron beam. And how can you stabilize the energy of the electron beam? You need, for that you will need stabilized acceleration voltage, or you can improve the gun design also. So improved gun design which can ensure stability of the beam. Next is aperture diffraction. The wave nature of electron causes the beam to diffract upon passing through a narrow slit. Each beam passing through the slit sets up its own waves. These will interact to give a bright spot in the middle and a set of concentric rings in the image plane, which are called as the airy disk. So how to reduce effect of diffraction? In order to reduce the effect of diffraction, it is necessary to have as great an angle as possible between the optical axis and the lens perimeter. That would amount to having no aperture at all. But we know that if you want to reduce spherical aberration, then you need small aperture. So, but a smaller aperture is needed to reduce the effect of spherical aberration and chromatic aberration, which would cause diffraction problems. Thus, an optimum aperture size must be chosen. Optimum size should be chosen so that you can reduce spherical aberration, but at the same time, aperture diffraction should not be increased to a larger extent. Next is astigmatism. So, what is astigmatism? Astigmatism refers to the improper shape of the beam. A point object is focused to two line foci at the image plane instead of a point, an ellipse occurs. What causes astigmatism? Defect in the focusing fields, which can be due to electromagnetic lenses, apertures, or others, imperfection in machining. So, all these are the parameters which cause astigmatism. How astigmatism can be corrected? It is corrected by a set of magnets which are called as stigmators, which are placed around the circumference of the column, and that will reduce the astigmatism. Thank you so much. Please like and subscribe.